some of them. But I guess let's start from the beginning. What is a web framework? So definition I pulled from the net is that it's a collection of packages or modules which allows developers to write web applications or services. So next question is, what's a web application? Web application, maybe a simple definition might be that it's a Python application that receives an HTTP request, does something with it, and then returns an HTTP response. Something like this. So an HTTP request comes in, usually a web server will handle it first, so Apache, Nginx, Green Unicorn, something like that. Then it's passed off to either a web framework or directly to the web application, handles it, turns it back out to the web server, and finally the web server handles transmission of the response. To illustrate this, we've got a simple HTTP request, GET request with a couple headers. We'll assume that we've got some kind of web server with a container to serve this code, so we're just doing a simple print statement and return 200 status and some HTML, and then we might get back a response like this, just the body of the, 200 status code and then the body of the response. So there used to be a couple ways to handle, or containers for web servers to serve JSON or Python applications, CGI and ModPython for Apache. Circa 2004, someone came up with PEP, WSGI, Web Service Gateway Interface, I think it is, and the idea was to create a standard interface for Python applications. So web servers can implement this interface, applications can implement the interface, and you can move your application between servers without much hassle. The interface looks something like this. It's a single function. The function gets two arguments, an environment dictionary. The environment dictionary contains everything that would be in the shells environment of the web server. It includes everything from the HTTP request, so the method, the host, URL, body, headers, everything, and then some WSGI specific environment variables as well. And the second parameter is a callable start response, which you can pass a status code and some headers, and it'll start your response with those. The reason this is necessary is because HTTP supports returning. You don't have to return everything all at once. You can start by returning the beginning of your response. So we notice that the status code and the headers start at the top. It lets you print that out, and then that way your final response that you're returning from this method is just a list or any kind of sequence of strings. Putting this together, this is maybe the simplest possible WSGI application. In this case, we're ignoring the environment. We are calling start response with a 200 status code and with a single header, and then we're returning a list of a single string. So we kind of have an idea of what web applications are. Why do we need a web framework? We've seen that we can write Python that interacts directly with WSGI. Well, most web applications are going to have very similar concerns. They all have to have a way to route a request. They have to have a way to validate input, persist data, and then return usually an HTML response. So instead of duplicating all that effort, web frameworks kind of pull all those concerns together and give you a way to save yourself from writing all that code. So let's take a look at each of these individually. So request routing is the process of going from some kind of URL to a function or some Python callable. There are a few ways to do this, and common ways that these are done in Python frameworks. The first is to use a decorator. So this is an example using Flask. We have a URL hello plane, and we use a decorator to decorate the hello view function. So whenever the web framework gets a URL that /hello plane, it knows to call this function. Most of the time, this will also support parameters in the URL, and the parameters will get passed into the function. And bottle and pyramid also support this kind of syntax. The next version is to use a list of regular expressions or some kind of pattern. This is an example using Django. In this case, we've got one URL, which is /article/ and then some 4-digit number. And our view is an importable callable at news.views year archive. So that'll likely be called with the year, and then that'll serve our request from there. And web.py and web2py also support similar syntax. And then the third is traversal or object dispatch. So the idea here is you start at the root controller. The root controller can either decide to serve the response itself, or it can delegate to a subcontroller. In this case, we've got one subcontroller registered called movie controller. So if the URL starts with /movie, it knows to pass the request on to movie controller. If we see in this example /movie/list, well, the movie controller knows it has a way to serve lists, so it'll do that. If it's some other URL that it doesn't know how to serve, it'll just 404 not found. And you can kind of nest these arbitrarily until the request gets handled. So a request has been routed, and now we need a way to deal with the data in the HTTP request. In this example, we've got another HTTP request that's a post. We've got an ID in the URL, it's 34, and we've got some post data in the body of the request. What we really want in our Python application is the rich data type. So we kind of want event ID as an integer. We want the details, the body of the request in a dictionary. And if we have something like a number, we want it to be an integer or float. If we have a date, we'd like it to be a date times a date and not just a string. So this process of validating and casting the input is kind of done in two phases. The first is to take the environment dictionary we get from WSGI and build it into a more useful object. So WebOb and WorkZoop are both libraries that allow you to do this. Some frameworks will use these, some frameworks will write their own version of this. And the idea is it pulls apart that environment dictionary and puts it into the attributes of this request object. So body is just a string of the body. Headers might be a dictionary of all the headers that you get in the request. Get would be a dictionary of all the get parameters. Post a dictionary of post parameters, so on. There's no real standard here. Everyone does something a little different, but the idea is generally the same. Once we've got like a nicer object, we still need to go in the extra step of converting things to rich Python types. So most frameworks will provide some kind of forms library. This is an example using, I believe it's WT forms. So the idea is you create a form class and you specify fields on the form. In this case, we've got a first name and last name field. And then we'll specify validators for it. Forms, you'll usually pass in HTML form data. So there's the flip side of that is that these also usually let you render the form. So instead of having to write all the HTML tags for the form, you can call myform.render, and that'll spit out the string to render this thing. And that's what that widget field is for. So if you want to customize how these things look, you would pass in a custom class for the widget, and yeah, it would display differently. These are really great for validating form data, as I said, but there's other categories of data we might get in. If we've got an AJAX request, we're going to get a Python dictionary in once we've passed it through Python's JSON module, or maybe, like we saw in our first example, we've got an integer in the path. We need some kind of general purpose validation library. So there is a library called Colander, which is provided as part of the Pyramid framework. And the idea here is that you're validating just a schema instead of post data. So it's code looks fairly similar. In this case, our input is a dictionary, and it's going to look for a name key and an age key, and then we'll try to validate these. We'll see the age, it's going to turn into an integer, and it's going to validate that it's between 0 and 200. Pyramid also supplies a deform library that lets you wrap up these Colander schemas and actually turn them into form libraries like other frameworks provide. And you could also use these validators on their own if you want to validate, say, just something in the path. So now that we've validated our input, we usually need to do something with the input we were given. HTTP is stateless itself, so our application has to take care of persisting the data. Common methods to do this are a relational database, key value store, or a document store. Key value stores and document stores generally map pretty well to object-oriented languages like Python. You can take a Python object, encode it with JSON or Pickle, and stick it as the value in the key value store and assign it any string key. Document stores are generally JSON documents, so you can, again, use the JSON module, encode the Python dictionary, and just stick it in. Relational databases, on the other hand, don't map very well. You're going from a relational representation with foreign keys and tables to an object representation. So for this use case, many frameworks provide ORMs, or object relational mappers. The idea here is you create a model class which kind of maps to a table, and you create fields or database columns You can assign them types and validators. We see strings have a length validator, and tell them which ones are unique keys. So the ORM will use this it can construct your tables for you. It can also construct select queries. You would do something like user.query and pass in like ID equals 5, and it'll construct the SQL query, return you that row. And you can also use it to insert. You can instantiate a user object, provide the fields, and say user.save, and that'll take care of constructing the insert statement. There are advantages and disadvantages to using an ORM. One of the advantages is that it's very easy to go from one database server to another. You can go from SQLite to MySQL, MySQL to Postgres. Your application shouldn't have to change very much at all because the ORM takes care of all the difference in the dialect between the servers. All right, so we've persisted some data, and now we need to return a response. There's kind of two common ways that we return a response in a web application. An AJAX call usually gets a JSON response, so again, it's fairly easy to just go from a Python dictionary, use the JSON module, encode it as JSON, return that as is. There's nothing really built into the framework for that. The other common case is returning HTML. So using this example, we might have a dictionary with a name and a location, and we kind of need to inject that into our HTML template at the right spot. So there are many HTML or general purpose templating languages in Python. Let's just take a look at a couple. First being Mako. So we see that the lines that start with percentage, those are Mako syntax. In this case, we've got a for loop, and in the for loop, we're calling this make row with each row from the list of rows. And then we see below that, we're actually defining a function in the Mako template itself, and then more Mako syntax to print out cells for each item in the row. So I'm not a huge fan because I don't like the idea of defining functions in templates. It makes it a little difficult to test. So there are stricter versions of templating language. So Jinja 2 and also Django has a templating library that basically works with the same syntax. In this case, you define tags. So in this example, we've got for tag. It iterates over navigation. In each item, we'll say we have substitution. So item.href, that string will just be placed into the href tag there. And then we also notice that item.caption has a pipe to lower. One of the nice things about this templating language is filters. So in this case, we're filtering the caption through this lower function, which will lowercase it. There's a lot of filters for sorting, sequences, for displaying, formatting dates, numbers, strings in different ways. And if you need any kind of customized tags, you can create a tag class, import it into the template, and you can still do customizations that way. And the third templating language I'm talking about is even stricter, is Mustache. So in this case, you don't even really have custom tags, you just really have this one type of tag that uses the pound sign. So in this case, depending on what the item is at that location in the dictionary, it'll know what to do. So the first pound items, it's a list, so it's going to iterate over it. Pound first, if it's the first item in the list, it'll do something special. Pound link, if that key exists in the dictionary, then it'll do that section of the template. All right, so that covers most of the common concerns. But we know that any medium to large size web application is probably going to need something in addition to those standard concerns. So a lot of web frameworks will also include ways to extend the default behavior. Using Django as the first example, it includes this thing called middleware, where it gives you, it's basically an interface where there's five hooks into that process. So you can process request, process view as the request is coming in, and then you can handle exceptions, template response, and the response itself as it's coming out. This is a diagram from Django docs, just to illustrate that, kind of going through all of the sets of middleware. Most web frameworks include some kind of extension to do something similar to this. Bottle uses hook decorators, so it's the same kind of idea. You can hook into before the request or after the request and customize the request and response objects in any way you need to. And Pyramid is kind of built around the idea of being able to customize everything. So in this case, provides hooks for handling errors, building the request, rendering responses, really everything. The main workhorse here is the idea of a tween, which is sort of for in-between, similar to Python, similar to Django's middleware. Difference being it's kind of more an open interface. You get a callable in, that's the view. You're able to do anything before you call the view. You call the view itself and then return the response at any point. All right, so we talked a lot about the concerns and the components the web framework will give you. In addition to all of that, I think one benefit of using a web framework is that it implements, it gives you conventions. So if you're working on a web application, you want to bring someone else on board. If you've written everything from scratch, it's going to take you a long time to bring that person up to speed. If you're using like a common web framework, chances are they're coming in at about 60%. They know where things are going to be laid out. They kind of understand what the different tools are. And it also gives you a lot of documentation. So whenever you do hit a blind spot, someone can reference that documentation. You don't have to write everything yourself. Saves you a lot of time there as well. I mentioned quite a few frameworks. I kind of feel like they break down into 3 categories. Your micro frameworks are generally geared around just getting started really quickly. They'll do request routing and they might do some serialization or persistence, but not much else. Flask model, Cherry Pie, all call themselves micro frameworks. The idea is you can probably start out with a single Python file, maybe like 20, 30 lines of code, and you have something that's going to serve fit the WSGI interface. The full stack frameworks try to really include everything. They'll usually come with some executables to like set up your environment, probably run test servers, hooks for testing, things like that. Django, TurboGears, Web2Py, all are quite large, include a lot of things. And then I feel like Pyramid kind of sits by itself. Its idea is that they created a bunch of components and they all work really well together, but you're not really required to use all of them. You can use Pyramid as like a fairly small core, and then things like Colander, it pulls in SQLalchemy, Deform, and it just each kind of concern is its own library that you can use individually, or you can use all together as in a Pyramid app. And that's about it. I included some links to some of the more common frameworks, and WSGI.org is a great reference for lists of Python frameworks, web servers that support WSGI, and a lot of details about the interface itself. Questions? So the question was, are any of them thread safe? I know Bottle makes an effort to work with G-Event so that you can do kind of an asynchronous. I don't know that any of them specifically aim to be thread safe. Python threads are only so useful. So I'm unfortunately not sure if any of them really go all out to try to make everything thread safe.
Curious whether you use any of these for your reports.
At work, we are using some of the Pyramid components, but otherwise not very much. I've used most of them on personal projects at one point or another.
Do you have any personal favorite?
I used to do everything in Django. I've started to move more towards the Pyramid way of doing things, just kind of pulling in the components you need and building things that way. For hackathons, I think usually like Flask or Bottle are great because they're just really quick, throw stuff together. You don't have to worry a lot about things. If you expect a project is going to grow pretty big, you're probably going to have to end up doing a lot more customization there, and you probably want to go for something like Pyramid or Django that's going to do more for you.
So for validators, are all validators generally done on the Python side of things, or do they even rely on like the database integrity constraints for that? Like is it going to be before it hits the database, it validates it as int between 0 and 200, or?
Right, so the question's about validators. Generally, it's as soon as you receive the input, the validators will run. Because, as you notice, like the form libraries and the ORM model libraries are quite similar. So some of them will attempt to allow you to generate like forms straight from the model, so you can define just your database model, and then pretty sure Django and WT forms works with SQL Alchemy to do that. So you, in an attempt to not have to duplicate all your validation, just saying like, give me a form class that works with this database model.
So you talked about kind of your favorite frameworks. If somebody was just kind of starting out trying to learn all these concepts, which framework or frameworks would you recommend to them?
So the question is, what would you recommend for a beginner starting out? I would say probably either Django or Flask are probably pretty straight. Actually, I guess Flask would be probably a good place to start on micro framework. That's pretty straightforward. I think it tries to lay things out fairly obviously, and you might not know how everything works under the hood, but it should be pretty obvious from your like first kind of page of code what's going on.
In Flask, when is it obvious you've gone too far?
Yeah, that's a good question. When is it obvious when you've gone too far with a micro framework? I suppose whenever you start writing something and you know that there's already a library that exists in one of the other frameworks, or I've never hit that myself, so I'm not too sure. For me, it's usually like, yeah, you start writing a lot of code and you have to sit back and say, wait a minute, there's probably an easier way to do this. Yeah, I think Flask is mostly for like really, really small applications, unless you're interested in writing a lot of it yourself.
For Django, did you ever use GeoJango? GeoJango.
I don't think I have. No, GeoJango, that's for geolocation stuff. Yeah, I haven't used that.
For these frameworks, are there communities that tend towards one such that there are no components available, or libraries or add-ons that are more available, for instance, for Django versus Flask?
I know the Django community is quite large. Django does their own user group meetups. Django's kind of built around the idea of apps, so you're supposed to build a bunch of small apps and kind of bring them together to make a whole application. And I know there's quite a few of those out there. I think Pyramid they're trying to kind of grow the community there as well. I don't know as much about the other ones, but I know at least those two have quite a large following and a lot of stuff built up around them. I think those are the two that really get used for larger projects. I think a lot of the micro frameworks tend to be